I'm Péter Galambos, the director of the Antal Bejczy Center for Intelligent Robotics. And I'm going to present you some of the useful robotization technologies. Robotization for food industrial SMEs. This is the title of my topic. And I'm going to show three kind of interesting robotization setups. I want to emphasize that these setups are not really deep rocket science, except of one, which means the second one actually, but rather off-the-shelf solutions that could be integrated directly into food industrial solutions. But first of all, I would introduce our laboratory in a more general way. So the laboratory is entitled by Professor Antal Bejczy, Tony Bejczy. Probably he was the most famous Hungarian roboticist. He worked for more than 25 years for the NASA JPL laboratory in Pasadena. His main results was in teleoperation and telepresence systems, especially in space robotics. We are very proud of him. And according to his research activity, we are focusing basically on teleoperation and telepresence, advanced applied robotics, cloud robotics, and medical robotics. And in advanced applied robotics, food industrial applications holds a quite large spectrum. Our main topics, I divided our focus areas in two columns. On the left side, there are the medical robotics stuff, and on the right side, we have the applied robotics focuses. I only emphasize some of these items: system design, future of manufacturing research, control engineering aspects, machine learning, and mainly the proof of concept validations of new technologies. It's a kind of offer to the community as a living lab that we are able to perform proof of concept validations of sensor technologies, robot technologies, or even more complicated processing technologies. These are some live pictures from the the lab. I shot this photo last November. Maybe one of my talented students worked overnight to finish his master thesis. So I'm also very proud of my great students. We often invite high school students to the laboratory to give them introductory lectures on different aspects of robotics. It is very important to do this in order to ensure the new generation appearance in our university and in the technical community in general. We are very committed in real-world problem solving and prototype building. That is why we are operating a virtual not virtual, but really physical prototype laboratory in which I took this photo. I will introduce it later on. And in international education activity, we often organize summer schools and other student exchange programs in which last November and this March, just before the pandemic, we organized a student exchange program with the Japanese University, Shibaro Institute of Technology, and hopefully we can practice it in the future after the pandemic. Yeah, these are the Japanese students on the top of a train, which is actually just in front of the university building. Our mission is basically the end-to-end innovation model, which means that we cover the innovation process from the formulas to the prototypes, and our staff is built up accordingly. We do have mathematicians, physicians on board, as long as engineers in mechanical, electrical, and software part of the problems. So as a result, we can provide a complete service to our partners, from exploratory research to practice-driven R&D and system integration. Robotics is a megatrend, as we know, so it is very hard to talk about pure robotics. As we learned from today's webinar, from the BME, from the ALTA presentations, robotics cannot be separated from other parts of Industry 4.0. We can only handle it as a co-evolving technology spectrum, and Internet of Things, robots, artificial intelligence, virtual and augmented reality along blockchain. Everything is here. It's a very dynamically growing market. So we definitely have to be on this trend. The yearly market growth is continuously over 15% per year. So it's a strong trend. Our R&D staff contains 4 postdoc scientists, 6 PhD students, 8 graduate students, which I usually call resident students, who are still in a student status, but working with us on our project, even with a contract. So let me say they spend about 12 to 20 hours a week to join our research activity. We also have 4 full-time engineers and the necessary administrative staff to cover the project necessities. Internationally, we are quite active in several organizations, mainly in IEEE, Robotics and Automation Society, Systems Managed Cybernetics, and Industrial Electronics societies. We are also a member of the EU Robotics ASBL, and we hosted several programs in the frame of this public body. That is why we try increasing our activity in Horizon 2020 and the upcoming framework calls and projects as well. We have, in the medical era, we have a strategic partnership with the Austrian Center of Medical Innovation and Technology. Standardization is important in Industry 4.0 and robotics. That is why we maintain a strong activity in different ISO and IEC standardization bodies. And to turn on the today topic of this webinar, we believe that the big meeting is what is very important currently. The latest AI methodologies, latest AI technologies moves into the brain of robots, which represents the cutting edge mechatronics. As we know, there are leading companies all over the world who can provide very dexterous robot mechanism and control electronics alongside, but the main question is how to control the latest mechatronics in order to achieve the real world problems in the different industries, including the food industries. My favorite example is that you can buy now a 5-finger gripper in any sort of robotics manufacturer or robotics web store. So it is easy to buy a 5-fingered robotics gripper, but currently nobody knows how to control the 5-fingered gripper in order to perform useful tasks in real-world situations. So, but now researchers, including us, working very hard on this serious issues, how to control the dexterous manipulation, and sooner or later these real-time design, real-time planning technologies will be available, and we would like to be on the start line to integrate those technologies in industrial solutions. Our laboratory is open for cooperation before any serious investment to try out a new technology or existing technology, and make it very clear and make a clear answer if the given technology is able to solve the task or not. And the programs by the government and by the EU can help a lot to answer these questions before starting to invest larger amounts in discovering these technologies. And I think this is the way how to go together with other living labs and with the SMEs to get funding to perform proof of concept validation projects and collect this experience on public surfaces, public websites, to demonstrate that really the robot technology, the AI technology, the industrial information technology can solve real-world problems with a tractable financial background.